Okay, students, in this lecture, I will explain some of the problems which I gave in the exam of traffic engineering, and these problems are related to volume studies and uh, drawing the speed flow curve for level of service analysis for multi-lane highways and freeways. So let us start. We'll start with the question related to volume studies. So in this question, the arrival volumes are to be calculated for an intersection, and these volumes are normally taken when the flow is more than the demand. So data which is taken is for each time period we have the number of vehicles departed, okay, and we have the queue length which is taken at the end of the time period. Okay, so between 6 to 6:15, 60 vehicles departed, there was no queue, and the next 15 minutes 95 vehicles departed and there was a queue of 31 vehicles. Okay, now for the first one, and there's an equation as well, but just for the record, the equation which will be used, it's not written here, I forgot to write it, but I believe you can easily understand it. Okay, so in the first time period 60 vehicles departed and there was no queue. That means these are the vehicles which arrived, so this is 60. For the next time period 95 vehicles departed, okay, so and there was no queue earlier, so obviously these 95 vehicles they came in this time interval. So 95, if there had been a queue earlier, I would have subtracted it. Okay, so there's no queue before, so this is 0, so 0 here as well. Then plus the vehicles which are in the queue, which is 31. Okay, so this gives me 126 vehicles. Okay, moving on. Then in the next time interval 59 vehicles departed, okay, and there was already a queue of 31 vehicles earlier, so 59, okay, minus 31 vehicles which were already there, plus 20 which are in the queue right now. Okay, so you subtract the previous queue, because these vehicles did not arrive in this time interval, they were already there. Okay, and then you add the present queue, because after subtracting the previous queue, whatever is whoever departed and whoever is in the queue, that is the number of vehicles which arrived during this time interval. Okay, so 59 vehicles departed and there was a queue of 31 vehicles. Okay, so 59 minus 31, so whatever the number you get, okay, these are the vehicles which have arrived, plus some of them, the vehicles which arrived, may have been left in the queue, so that's why plus 20, the present queue value. Okay, so this gives me okay, so again for the next one it will be 74 the vehicles which left, minus 20 from the previous queue, because these vehicles were not new, they were already from the previous queue, plus 35 whoever is left in the queue from the present arrivals. So now the number is 89. Okay, so in this way we'll be calculating the rest of the numbers. Okay, so this is the answer, these are the answers for your record, and just a note about the last number, because these numbers were generated randomly, these are not actual values, so in the end I got a negative number. It should not come, okay, there should not be any negative number of vehicles arrived, but the numbers are generated randomly, so that's why I got a negative number, and this should not happen. Okay, any real data would not give you a negative number of vehicles arrived. Just to refresh what we did, so we wanted to calculate number of vehicles arrived, okay, and the number of vehicles arrived was calculated as the number of vehicles which departed, and these vehicles cannot be equal to number of vehicles arrived because some of them were already in the section from the previous queue. So I subtracted the number, the people or the vehicles which are already there, and then I added that number which was left in the queue after this session, after this time period. Okay, so this is how we calculate these numbers. Now moving on to the next example, which is related to the calculation of a speed flow curve or drawing of a speed flow curve. So I'll just try to plot, I'll show you the calculations and I will make a rough sketch out of the plot. Okay, and obviously if you have the scale and you know the values, you can plot it yourselves. Okay, so the first thing which we need to calculate in all these examples is the free flow speed. The free flow speed is this value, the factor for lane width minus the factor for lateral clearance. Now remember, it's a freeway, and then we have the factor for the ramp density itself. Okay, so the lane width is 11 feet. If I go to the table, then for 11 feet lane width, you can see the factor over here is 1.9. Okay, then factor for lateral clearance. Lateral clearance we only need for on the right hand side because it's a freeway, so which is 4 feet. So for 4 feet, it's a 4-lane freeway, so 2 lanes in each direction. Okay, so the factor is 1.2. Okay, then the ramp density. You can see it's written here, 4-lane freeway. So this comes out to be 66.5 miles per hour. You want to take more decimal places, no problem. Okay. Now the other things which I want to calculate are breakpoints. The other important points on the curve are breakpoints and capacity. How they go on the curve, I will explain after finishing these values. Okay, so the breakpoint, we have the equation over here. This is the equation for breakpoint. We are not applying any adjustments, so it's basically 1000 plus, okay, so this one 1000 plus 40 into 75 minus the free flow speed. Well, free flow speed is 66.5, which we just calculated. Okay, so after using that equation, it comes out to be 1338.59 passenger cars per hour per lane. Let me just check. 56, sorry. Okay, the next thing I need is the capacity. We use capacity with a small c. So now the equation for capacity again is given here, 2200 plus 10 into free flow speed minus 50. So let us do that. Okay, so the capacity comes out to be 2365 passenger cars per hour per lane. Okay, just a note here, usually I don't, or even in the book, they don't keep the decimal places of anything related to flow rate. So I'll make this one as 39. Okay, and the capacity is this one, and there's a check on capacity as well, that for freeways the capacity should not be more than 2400. It isn't more than that value, so it's fine. Okay, now so we have got 3 important points on the curve. Okay, I need some other points which should be between breakpoint and capacity, and by other points I mean that I need to find out the speed values as some of the other flow rates which happen to be between capacity and breakpoint. Okay, so the capacity is, you can see here, 2365, and the breakpoint is 1339. Now to draw the curve, so the curve is between basically these 2 points. To draw the curve, I will use this equation. Okay, I already know everything, and like I said earlier, there are no adjustments. So I know free flow speed, I know capacity, I know breakpoint. I need to and the value of A, again I will take it from this table. So I need to just assume like 2 or 3 values of Vp, which should be between breakpoint and capacity. I cannot go above capacity or below breakpoint. Below breakpoint there's no curve, and above capacity again no curve. So I have to find out or assume some values of Vp between breakpoint and capacity and find out the value of speed. Okay, so let me take some values and I will find out the speeds. Okay, so these are the values which I assumed. Okay, and you can see all of them are between BP and capacity, and these are the speeds which I got. Okay, and as I said, you can round them off to the first decimal place. There's no problem with that. Okay, let me just do this. Okay, so Vp is in passenger cars per hour per lane, and the speed is in miles per hour. Okay, now how do we draw the table here? Okay, so or the speed flow curve here. So first of all, let me make the axes here. So this one, the vertical axis, this one, the horizontal axis. So horizontal axis will be Vp and vertical axis will be the speed. Okay, so speed, this value, I'll start with a very straight line, and this value should be the free flow speed. Okay, so this I'll start from a value of 66.5, which is my free flow speed. Okay, and this will continue till I reach the break point. Okay, so this point is my break point, which is 1339. Okay, up to the break point it is a straight line. Okay, then after the break point you will plot according to these coordinates. Okay, and you will go up to capacity. Okay, so your last point will be capacity, so there will be a point here with the capacity. Okay, now I'll draw a freehand curve. Okay, so from here I'll draw a curve up to capacity. Okay, so this point I know is capacity 2365. Okay, so 2365 is on the x-axis. Okay, because the flow rate and the break point and the capacity are on the x-axis. Okay, so this is located on the x-axis. Okay, so I was saying the break point is here, and the capacity is also, you will locate it on the x-axis. Okay, then these Vp values are the x values, okay, for this curve. Okay, and the s values are here, the y-axis values. Okay, so now you have between this point and this point you have 3 more points, so you mark these points over here. Okay, so I don't know how should I mark the point, but anyways, let's say this is my point. Okay, so its x value will be 1400, and this point will have y value of 66.1. Then the next one here, and there is another one here. Okay, so in each case you know the x value which is from this column and the y value from this column. Now just to refresh your mind, these values are assumed and these values are calculated from the speed equation, this equation. In all these calculations the critical density was taken as 45. Okay, so this is from one of them. You save it. Okay, then I will move on to the other one. Okay. So in this example, we are calculating number of vehicles accumulated in the area. Okay, so I'm again starting with the example related to the volume studies. So they did a volume study for an area. Basically, you call it a cordon study, a cordon count. And what they did when they started the study, for the first hour, they just found how many vehicles are already in the area, which is 200. Then for the rest of the hours of the study, they counted number of vehicles left the area, number of vehicles entered the area, arrived and departed. Using these two counts and the first one, we will calculate the number for accumulation of vehicles in the area. Okay, so how do we do that? Now 200 vehicles are already in the area when we started the count. So I will and 312 arrived. So 312 arrived plus 200, which are already in the area. Okay, so this is the total accumulation. Okay, consider the previous one. Then subtract 130 which departed during this time interval, so they are no longer in the area. So 130. Okay, so this will be 330 minus 312, so 18. Okay, so 18 vehicles in the area right now. Okay, the next one, 559 arrived, so I should add them, plus 18 who were already in the area, minus 336 who left. Okay, so this will give me 241. Okay, so in the same way you will calculate the rest of the values. Okay, so these are the rest of the values just for your record, but their numbers are calculated in the same way. You take the number of vehicles which arrived in your hour plus the number of vehicles which were already there, okay, and minus the number of vehicles which have left in the hour. So obviously the remaining is the number of vehicles which are existing in the area at the end of the hour. Okay, next example is related to, again, for a speed flow curve but for a multilane highway. Okay, so the first thing which will change is the calculation of the free flow speed. Free flow speed will be the base free flow speed minus the factor for lane width, factor for lateral clearance, factor for median, factor for access point. Okay, base free flow speed is given 65. Lane width is given 11 feet. For 11 feet lane width, we already know the factor which we used in the last example as well. There's a table for that. So 1.9. Okay, factor for lateral clearance. Now lateral clearance is required because it's a multi-lane highway. So we take total lateral clearance. So left plus right. Okay, so total 10 feet. And it's a 4-lane multi-lane highway. Okay, so 10 feet lateral clearance, 4-lane multi-lane highway. So 4-lane multi-lane highway, 10 feet lateral clearance, the factor is 0.4. Okay, then factor for median type it is divided or undivided. It is divided. For divided, the factor is 0. Factor for access point, we have 30 access points per mile. It's given here. So I will go to the table. Access point density, this is a table for 30 access points. The value is 7.5. 7.5. So this comes out to be 55.2 miles per hour. So this is the free flow speed. Now the second thing which we did in the last example, that was the calculation of breakpoint. For multi-lane highways, the breakpoint is constant, no change, 1400. Whatever type of multi-lane highways it is, we don't need to do any calculations. Capacity, again we'll use the capacity equation. Capacity equation is this one. Okay, so very similar to freeway, but numbers are changed. Okay, so free flow speed we just calculated. Okay, so use the free flow speed to calculate the capacity. Okay, so the capacity comes out to be 2104 passenger cars per hour per lane. Okay, now I will use the same approach which I used earlier, and I will calculate some more speeds using the or assuming the VP between the breakpoint and the capacity. Okay, now the only thing here is I've already done it, but you can see here the equation needs A, and the value of A is different for freeways and multi-lane highways. Otherwise, I could have used the same value. And one more note here, since it has appeared now, the capacity of multi-lane highway should not be more than 2,300. So our is 2,100 something, which is fine. Okay, so I was saying that the speed equation uses the A value. So A value is changed, so that's why the values which I calculated for freeways cannot be used in this example. So I have to make my own values now, or recalculate. I can keep the same VPs because the breakpoint is still has all the same range from 1,400 to 2,100. So the range of VP, or the values which I assume for VP, can remain the same. Okay, so a couple of actually a lot of changes. Breakpoint has changed, the capacity has changed, the VP value has to be more than the breakpoint, because if you are taking the breakpoint, then it's the free flow speed. We already know that. Okay, so these are the values for VP which I assumed, and these are the S values which I calculated from this equation. Okay, the breakpoint 1,400, capacity calculated, DC same, free flow speed which we calculated A value from this table. Okay, so again, if I plot the curve, it will not look different actually. The shape of the curve is same. So if I draw it again, this is for y-axis the speed, and then I have x-axis the VP. Okay, and I will start with the free flow speed. So this line indicates the free flow speed, which is 55.2. we already calculated. Then it will go up to the breakpoint, which is 1,400. Okay, so this value corresponds to the x-axis. Okay, and then I will mark a point here for capacity. So here is my capacity somewhere. Okay, just a point, and the value is 2,104, which we already calculated. In between them, I have plotted a curve. Okay, sorry for this. Okay, but a smooth curve, as smooth as you like. Okay, and the values again, these are the x values and these are the y values for the points between these two. Okay, so there are 3 points between them. One is, let's say, here, the other one is here, and the next one is somewhere here. Okay, so for each of these points, the x will be taken from here and the y will be taken from here. Okay, as I was doing the calculation for this example, I realized that in the freeway example I made a calculation mistake. Okay, but I will already showed you the equation and the numbers, so you can correct. The mistake is only in the calculation of these points. Okay, the s values, that's it. Okay, everything else was correct. Okay, so I hope you have understood the procedure, and all the best.